When remodeling a residential kitchen and installing both a wall oven and a cooktop, it's essential to properly size the electrical circuit to ensure safe and compliant operation. This explanation focuses on how to calculate the appropriate amperage for a single circuit feeding both appliances, referencing the National Electrical Code, specifically Section 220.19. In this scenario, a wall oven is rated at 8.9 kilowatts and a cooktop is rated at 7.4 kilowatts. The combined load totals 16.3 kilowatts. The NEC allows us to treat this combined load as a single range according to Section 220.19, Note 4. This simplifies the calculation process. Note 1 of NEC Section 220.19 provides guidelines for sizing the circuit for a single range. It states that a single range can be sized at 8 kilowatts for a 240-volt circuit. However, since the total load of the oven and cooktop exceeds 12 kilowatts, an adjustment factor must be applied. The adjustment involves adding 5% for every kilowatt, or major fraction of a kilowatt, by which the total load exceeds 12 kilowatts. In this case, the combined load of 16.3 kilowatts exceeds 12 kilowatts by 4.3 kilowatts. Because we only count major fractions, that number is 4 kilowatts. Therefore, we need to add 5% for each of those 4 kilowatts. This equates to a 20% increase in the base 8 kilowatt value. To calculate the adjusted load, multiply the base 8 kilowatts by 1.2, which represents the 20% increase. 8 kilowatts multiplied by 1.2 equals 9.6 kilowatts. Now, we need to convert this kilowatt value into amps to determine the appropriate circuit breaker size. To do this, we use the formula amps equals kilowatts times 1000 divided by volts. In this case, the voltage is 240 volts. So, the calculation is 9.6 kilowatts times 1000 divided by 240 volts. This results in 40 amps. Therefore, a 40 amp circuit is sufficient to supply the combined load of the 8.9 kilowatt wall oven and the 7.4 kilowatt cooktop when treated as a single range, according to NEC Section 220.19. Let's break down the steps again to ensure clarity. Firstly, determine the total combined load of the wall oven and cooktop. In this case, it's 8.9 kilowatts plus 7.4 kilowatts, which equals 16.3 kilowatts. Secondly, refer to NEC Section 220.19, Note 4, which allows treating the combined load as a single range. Thirdly, refer to NEC Section 220.19, Note 1, which states that a single range can be sized at 8 kilowatts for a 240-volt circuit. Fourthly, determine the amount by which the total load exceeds 12 kilowatts. In this case, it's 16.3 kilowatts minus 12 kilowatts, which equals 4.3 kilowatts. Fifthly, since only major fractions are counted, consider the excess load to be 4 kilowatts. Sixthly, calculate the percentage increase by multiplying the excess kilowatts by 5%. In this case, it's 4 kilowatts times 5%, which equals 20%. Seventhly, calculate the adjusted load by multiplying the base 8 kilowatts by 1.2. This result is 9.6 kilowatts. Eighthly, convert the adjusted kilowatt value to amps using the formula amps equals kilowatts times 1000 divided by volts. In this case, it's 9.6 kilowatts times 1000 divided by 240 volts, which equals 40 amps. Therefore, the circuit can be sized at 40 amps. It's crucial to consult the specific requirements of the local electrical code and regulations, as they may have additional requirements or amendments. This explanation is based on the NEC, but local codes may vary. Always consult with a qualified electrician to ensure compliance with all applicable codes and regulations. When selecting the appropriate wire size for the 40 amp circuit, refer to NEC Table 310.15b16, which provides ampacity ratings for conductors based on their insulation type and installation method. For example, if using type THHN copper conductors installed in a raceway or cable, a minimum of number 8 American wire gauge (AUG) copper wire would be required, as it has an ampacity of 40 amps at 75 degrees Celsius. Remember to select a wire size that is suitable for the termination temperature ratings of the circuit breaker and appliances being connected. It's important to ensure that all electrical connections are made properly and are tightened to the manufacturer's specifications. Loose connections can cause overheating and potentially lead to electrical fires. Also, consider the distance of the circuit run from the electrical panel to the appliances. If the distance is significant, voltage drop may become a factor. Voltage drop occurs when the voltage at the appliance is lower than the voltage at the panel due to the resistance of the wire. If voltage drop exceeds 3%, it can negatively impact the performance of the appliances. To mitigate voltage drop, a larger wire size may be required. Voltage drop can be calculated using online calculators or by consulting with an electrician. The NEC provides guidelines for voltage drop in informational note number 2 to section 210.19 AON. It recommends limiting voltage drop to 3% for branch circuits and 5% for feeders plus branch circuits. When installing the circuit breaker, ensure that it is properly sized and rated for the intended application. A 40 amp circuit breaker should be used for this circuit. The circuit breaker should be installed in a panel that is properly grounded and bonded in accordance with NEC requirements. Grounding and bonding are essential for electrical safety and help to prevent electrical shock hazards. The grounding system provides a low impedance path for fault current to return to the source, which allows the circuit breaker to trip and to energize the circuit in the event of a ground fault. Bonding ensures that all metal parts of the electrical system are at the same electrical potential, which reduces the risk of electric shock. When connecting the appliances to the circuit, follow the manufacturer's instructions carefully. Ensure that the appliances are properly grounded and that all connections are tight and secure. Use appropriate wiring methods and connectors for the installation. For example, flexible metal conduit FMC or armored cable AC may be used to connect the appliances to the junction box. When working with electrical circuits, always to energize the circuit before making any connections or performing any work. Use a voltage tester to verify that the circuit is de-energized. Wear appropriate personal protective equipment, PPE, such as safety glasses and insulated gloves. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Electricity can be dangerous, and it is important to take all necessary precautions to ensure your safety and the safety of others. The NEC is a comprehensive set of standards that covers a wide range of electrical topics. It is important to stay up to date on the latest edition of the NEC and to understand its requirements. The NEC is updated every 3 years, and new editions are constantly being released. You can purchase a copy of the NEC from the National Fire Protection Association, NFPA, or from other retailers. You can also find information about the NEC online at the NFPA website. In addition to the NEC, there may be other local codes and regulations that apply to electrical installations. It is important to check with your local authorities to determine what codes and regulations are in effect in your area. Local codes may be more stringent than the NEC, and they may have additional requirements that you must follow. When planning an electrical installation, it is always best to consult with a qualified electrician. An electrician can help you to determine the appropriate wire size, circuit breaker size, and other components for your installation. An electrician can also ensure that your installation is compliant with all applicable codes and regulations. Hiring a qualified electrician can help to prevent electrical hazards and ensure that your electrical system is safe and reliable. In summary, sizing a single circuit for a wall oven and cooktop involves calculating the total load, applying adjustment factors based on NEC section 220.19, converting the adjusted load to amps, selecting the appropriate wire size, installing a properly sized circuit breaker, and following all applicable codes and regulations. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Remember to consider factors such as voltage drop and termination temperature ratings when selecting components for your electrical installation. By following these guidelines, you can ensure a safe and compliant electrical installation for your residential kitchen remodel. Furthermore, consider the potential for future upgrades or additions to the electrical system. If you anticipate adding more appliances or increasing the electrical load in the future, it may be prudent to install a larger service panel or run additional circuits to accommodate the increased demand. Planning for future needs can save time and money in the long run. Also, be aware of the different types of circuit breakers available and their characteristics. Common types of circuit breakers include standard thermal-magnetic circuit breakers, ground fault circuit interrupters (GFCIs), and arc fault circuit interrupters (AFCIs). GFCIs are designed to protect against electrical shock by detecting ground faults. AFCIs are designed to protect against electrical fires by detecting arc faults. Arc faults are dangerous electrical conditions that can occur when insulation on wires becomes damaged or when connections become loose. The NEC requires the use of AFCIs in many areas of the home, including bedrooms, living rooms, and dining rooms. Ensure that you are using the appropriate type of circuit breaker for each circuit in your electrical system. When installing electrical boxes, be sure to use the correct type of box for the application. Electrical boxes are available in various sizes and materials, including metal and plastic. The NEC specifies the minimum size of electrical boxes based on the number and size of conductors that will be installed in a box. Also, be sure to use the correct type of connectors for the conductors that you are using. Different types of connectors are available for different types of conductors, such as copper and aluminum. Using the wrong type of connector can lead to loose connections and overheating. When running wires through walls and ceilings, be sure to protect the wires from damage. Use cable staples or cable ties to secure the wires to the studs or joists. Avoid running wires over sharp edges or through areas where they could be easily damaged. When making splices and wires, be sure to use the correct type of splice connectors. Wire nuts are commonly used for splicing wires in electrical boxes. Be sure to twist the wires together tightly before installing the wire nut. Also, be sure to use the correct size of wire nut for the number and size of wires that you're splicing. When installing lighting fixtures, be sure to follow the manufacturer's instructions carefully. Ensure that the fixtures are properly grounded and that all connections are tight and secure. Use appropriate wiring methods and connectors for the installation. When installing receptacles, be sure to use the correct type of receptacle for the application. Receptacles are available in various ratings and configurations. The NEC specifies the type of receptacle that is required for different locations in the home. Also, be sure to install tamper-resistant receptacles in areas where children are likely to be present. Tamper-resistant receptacles have shutters that prevent foreign objects from being inserted into the slots. When working with aluminum wiring, be extra cautious. Aluminum wiring is more prone to corrosion and overheating than copper wiring. If you have aluminum wiring in your home, it is important to have it inspected by a qualified electrician. An electrician can determine if the wiring is safe and can recommend any necessary repairs or replacements. When replacing electrical devices, be sure to use devices that are rated for the same voltage and amperage as the original devices. Using devices with lower ratings can lead to overheating and failure. Also, be sure to follow the manufacturer's instructions carefully when installing replacement devices. When troubleshooting electrical problems, always start by checking the circuit breaker. If the circuit breaker has tripped, reset it. If the circuit breaker trips again immediately, there is likely a short circuit or overload in the circuit. Disconnect any appliances or devices that are plugged into the circuit and try resetting the circuit breaker again. If the circuit breaker still trips, call a qualified electrician. Do not attempt to repair electrical problems yourself unless you are qualified to do so. Electricity can be dangerous, and it is important to take all necessary precautions to ensure your safety and the safety of others. Remember to always prioritize safety and consult with a qualified electrician if you have any questions or concerns about electrical installations or repairs.